All right, here's another example for uniform circular motion. So we have a boy whirls a stone in a horizontal circle of radius 1.5 meters and a height of 2 meters above the ground. The string breaks and the stone flies off horizontally and strikes the ground after traveling a horizontal distance of 10 meters. What is the magnitude of the centripetal acceleration of the stone during the circular motion? So this is kind of a combination of uniform circular motion and horizontally launched projectiles. So this is something that you might see on a quiz or a test coming up. Hint, hint. All right, so we have this string breaks and then it flies off horizontally and then lands 10 meters from where the boy is standing. Okay, now we also know that the radius of the circle is 1.5 meters. The height, so our y displacement is 2 meters. And then that's all that we know. So if we want to know the magnitude of centripetal acceleration, again, we know that centripetal acceleration is equal to v squared over r. We know radius, but we don't know what velocity is. And that's going to be the velocity of the stone as it flies off and then travels that 10 meters and hits the ground in the horizontal direction. So in order to find acceleration, we first have to find that velocity. So in order to do that, we need to use projectile motion, right? Stuttered a little bit right there. We need to use projectile motion. So remember, we split this up into x and y directions. Now I know in my x direction, I know the range is 10 meters. The y displacement is going to be a negative 2 meters because it goes down 2 meters. I also know that the acceleration in the y direction is equal to negative 9.8 meters per second squared. I also know that the initial velocity in the y direction is equal to 0, and that's because it's horizontally launched, right? Because it's horizontally launched, that means that the only velocity, initial velocity, is in the x direction. So because of that, I can now find time with my stuff in the y direction there. Because in order to find the velocity in the x direction, I need to find time first. So using the second basic equation, we get delta y is equal to v initial y times time plus 1/2 acceleration times time squared. Our delta y was a negative 2 meters equals 0 because v initial y is 0 plus 1/2 times negative 9.8 meters per second squared, our acceleration, times time squared. So we get a negative 2 meters is equal to a negative 4.9 meters per second squared times t squared. We divide both sides by negative 4.9. And so we get t squared is equal to 2 divided by 4.9, which is 0.408. And then we'll take the square root of both sides. And we get that time is equal to 0.64 seconds. So now that we have the time, we can then plug it back into the x direction equation, which is the constant velocity equation, because remember, in projectile motion, there's no acceleration in the x direction, the horizontal direction. So in order to find the velocity, we get the range, which was 10 meters, divided by the time, which we just found to be 0.64 seconds. And we get that the velocity in the x direction is equal to 10 divided by 0.64, which is 15.625 meters per second. And then now we can use this equation to solve for centripetal acceleration. So we get centripetal acceleration is equal to v squared over r. So v was 15.625 meters per second. We square that, divide by the radius, which was 1.5 meters, and that was given in the problem. So I'm going to square this answer and then divide by 1.5. And I get the acceleration is equal to 162.76 meters per second squared.